of Kansas and Penn State University. He is an expert in conservation genetics and has been involved with research on several endangered species, including Mexican wolves, desert bighorn sheep, and Florida panthers. Today he's going to talk about genetic rescue in small populations.
It's my pleasure to be here. I actually came to Davis for a year in 1975, probably before many of you were born, and it was a great time for genetics at that point. I was in the Department of Genetics, and Dobzhansky and Stebbins and some of the greats of evolutionary biology were here at that point. But I was going to give you one little story from that time. This is when I met Michael Soule, and he had come up here and was talking about heterozygosity in endangered species, and people were kind of looking at him like, what are you talking about? You know, there was not really any awareness of conservation at that point, but he was trying to bring genetics into thinking about endangered species, and so he was really pushed genetics into the forefront for conservation biology. Maybe some people would say it was overemphasized, but I think at this point now we've got the tools with genomic data to really use genetics in a lot of ways to help endangered species. So I'm going to give a fairly specific example of that, and this is talking about something calling genetic rescue, and I'll give you some examples of it to show you how it may be helpful. I don't want to say that it's the end-all, because sometimes if it's not applied properly, it can not work out, and I'll give you some examples of that. So just as background, we can talk about different kinds of genetic variation. I'm going to talk primarily about detrimental variation, variants that have a detrimental effect on fitness, and usually we talk about those that are accumulating from inbreeding. And this is when people started talking about genetics and conservation, this is what everybody was concerned about, is low fitness due to detrimental variation. And there's different kinds of detrimental variation, and what I'm going to talk about here is this general phenomenon of a population having high frequency of detrimental variance, and so you could call this a genetic load for the population. This is a little bit different than inbreeding depression because every individual in the population has a low fitness. And so we have this in some examples. I'll give you an example of Mexican wolves here in a minute. And the way you can get rid of this detrimental effect is to introduce individuals from another population or another lineage in the Mexican wolf example. And this increases the fitness over what it was below this level, from this level that it had gone to. I've given some citations down here if people want to look up more details about various things. I think the students know all of this. I'm a little embarrassed because they probably know more than I do about this, but they haven't spent a semester reading all these papers of ours, so they're probably way up to date on these things. So when is genetic rescue a management option? And I and Rich Fredrickson, we came up with some guidelines, and I'm not going to go in great detail about these, but genetic rescue is a management option that I think might be more and more common because populations are small and isolated and have low fitnesses. And so what do you do in those situations? And so kind of methodically go through some ideas here I think is what you need to do before you start doing genetic rescue. And so, for example, does the population have low fitness? And like the Florida panther, people could go through and say, yes, they have 2/3 of the males that don't have 2 descended testicles. They have very low sperm quality. Yeah, yes, there's real problems in Florida panthers. Is there a donor population nearby? Well, in the Florida panther case, there were Texas cougars brought in. So is there, and that's, some would say even the same subspecies, but it's certainly the same species. And so you have some population that could come in that has a higher fitness. And in theory, it would be great to have data to support what you're doing. I got a call last week about the devil's hole pupfish and whether they should bring in fish from another, quote, species and save the devil's hole pupfish in genetic rescue. Well, you know, it would be great to have some data to support how that might work before you do it. And some other protocol that just is management. If you're going to do this, make sure that you can do it appropriately and follow up. And then I think one thing we have to appreciate here is this might not always work. In other words, it may work too well, and I'll give you some examples of that, where some animals and their offspring reproduce very well, and the population is overcome by these new individuals, and that ancestry dominates the situation. So let's say you have a population of a small number, and now you have a new individual that comes in, and I'll give you an example of the Isle Royale wolves, and that male that was brought in, his ancestry is 56% of the population after that happened. So one animal. So you kind of have this swamping and small effective population size as a result of this too successful genetic management. And so we have to think about the consequences of this and be able to manage given those consequences. So I'm going to give you these three examples of genetic rescue, and these are all different in some respects. I thought that would be a useful aspect to bring up here. The Mexican wolves, this is a population that's was extinct in the wild, was in captivity, and there was one lineage in captivity, descended from 3 animals, and there were 2 other potential Mexican wolf lineages in captivity, each descended, it looks like, from 2 animals. And were these real Mexican wolves or not is a question, and it looks like they were from genetic data, and so these different lineages were crossed, and those crosses seem to have a higher fitness as best we can measure them. And so this was an extinct in the wild population, descended from 7 animals. The Florida panthers, the wild population was small, probably 20 to 30 animals when Texas cougars were brought in. And so that population, there was active management involved, but not as extreme as this, where they were all captive animals. And the third example is the Isle Royale wolves, which is a park island in Lake Superior. This population is small. It's always been pretty small because the island is not that large for wolves. And there was natural immigration of one animal into that population. So there was really no management, and they're discussing what management there might be in the future because of recent problems with that population. So the Mexican wolf, extinct in the wild, descended from 3 lineages. It was reintroduced in 1998 in Arizona. Population as of last week, the census at the end of 2011, early 2058. Everybody would hope it would be several times at this point. So this is not doing as well as we would like. One of the big problems is illegal killing. 35 or more, we don't know, animals have been shot. There really hasn't been as good an effort as a lot of people think to stop this illegal shooting. And so that's a big problem. And then also, we think that there's genetic load. In other words, the population has low fitness. And so here's Roy McBride, who is a great big game hunter, and he was hired to kill wolves back in the 70s, 60s, and very successful doing this. And then when they realized that they were endangered, they hired him to capture some wolves. So, you know, the people that know more about these animals than anybody are the ones that are hunting them and killing them. And he actually was the person that rediscovered Florida panthers. They thought Florida panthers were potentially extinct, and how he works for the Florida Panther Project, he and his sons. So he's quite a hunter and very good at catching animals for captivity and for documenting how many there are in the Florida panther situation. And so the Mexican wolf, this is the historic range. They've now been released to an area here between Arizona and New Mexico, and that's where the 58 animals, as estimated recently, are. And the Mexicans now have released some 5 animals in Mexico. I don't know any details about that, if anybody knows how they're doing, but this is late last year. And so there's the Mexicans are trying to start a population of Mexican wolves at this point. Unfortunately, it's not going to be connected because of the wall across the border there. But anyway, so there is some real effort, but sometimes we talk about management, whether the effort is appropriate here. People would certainly question as far as on the U.S. side. So the Mexican wolves, when we got involved in them, looking at them, we could estimate the inbreeding coefficient because they were all captive animals. And so we had a pedigree. And so they were brought into captivity around 1980, and they ended up by around 2000, the late 1990s, that the average inbreeding coefficient was about 0.2. Inbreeding coefficient from a brother-sister mating is 0.25, so they were very inbred. And so the question was, what do we do about this? Because it looked like other things were happening, litter size and survival, other things may have been suffering. And so 2 other lineages, the Ghost Ranch and the McBride lineage, were crossed into this captive lineage. The McBride lineage was called as kind of in honor of Roy, I guess, because he caught the animals that started that lineage. And here's the cross lineage, and you can see the inbreeding coefficient is quite low because you're crossing between populations that are unrelated. They're each inbred, but they're unrelated in ancestry from each other. And so we've looked at various fitness measures, and I'll give you some examples of what we found in captivity and what we found in the wild population. So the ones with low inbreeding, low F, the litter size was above 0.4. As over time in the McBride lineage, the litter size declined. And so we could call this inbreeding depression because there's higher levels of inbreeding. And this is barely significant. There was some effect, but it's not a great effect. When we crossed between these different lineages and reduced that inbreeding coefficient, then we found that the litter size was 8, nearly double. So what we've actually done here is what I would call genetic rescue. We've crossed between 2 different lineages, 2 different populations, and now we've covered up these detrimental alleles, variants that were in this population here, and now we have higher fitness. And we found similar things for viability and other characteristics as well. And we also have some data from the wild population, the reintroduced population, and this is, here on this axis we have inbreeding coefficient, and the ones that are the McBride lineage with high inbreeding coefficient are these open circles up here. They have low litter size. The ones that are the cross lineage wolves are the closed ones, and they have a higher litter size in the wild. And so this takes into account some early juvenile mortality. You don't know exactly what the litter size is as well as in the captive situation. So we saw this impact, this genetic rescue in both captive and in the wild population. So Florida panthers, low fitness by a number of different characteristics, low genetic variation. They look to be kind of a subset of other North American pumas. They don't have very many variants that are different from Texas cougars, but they have less variation. And so 8 females were introduced, 5 contributed, 1 contributed a lot, so this is the kind of thing I think you have to worry about. You know, 1 of these 5 females was very successful, and actually the 4 altogether, or the 5 altogether, they contributed like over 40% of the ancestry of the contemporary population. So they've been almost too successful. And our goal, I was on some planning teams about this, our goal was to go to about 20% ancestry and evaluate things, and management managed to see that it didn't get too high because some people wanted to keep some Florida panther unique ancestry preserved. I don't know whether that's necessary, but we certainly could have evaluated rather than just let it go on up to where it is now. And so at this point, there's around 100 in the wild. So it's been pretty successful. So there's a Florida panther treed. You know, the way Roy McBride and lion hunters chase pumas are with dogs, and so the dogs have treed this lion. And here's the kinked tail that you find in a high proportion of Florida panthers. And so this is a frozen right angle in the tail. I don't know how detrimental it is, but certainly in house cats, you don't want that in your house cat. So it's not a positive thing, but it's very typical of the Florida panthers before the Texas cougars were brought in. So here's a summary of some of these traits that were in Florida panthers before they were brought in, before the Texas animals were brought in. 68% of the males didn't have 2 descendant testicles. They had generally 1 descendant testicle. They had very low sperm quality. Some of them could actually reproduce, but you know, this is obviously pretty extreme. 90% had a kinked tail, and then there's a cowlick that was pretty typical. And there's other medically related things that were found in the Florida panthers. After crossed with the Texas animals, the F1s, all of the animals had descended testicles. None had undescended. All of them had normal tails, and 38%, only 38% had this cowlick. So we saw a big change as far as this genetic determined variance in the offspring of these animals that were brought in. It'd be great to have these genes identified so we could actually know what's going on, because they're still obviously in the population and might be a problem again in the future. And so here's the Roy McBride's data on the numbers of Florida panthers. And you can see low numbers, his estimate 20 to 30. In 95, when the Texas cougars were brought in, it went up really dramatically. And another thing I want to point out here is this is without mortalities, the estimate, and this is with the annual mortalities. In this case, it's not killing, it's mainly traffic accident mortality. And so there's a very large number of Florida panthers that have been killed by traffic accidents. I was just talking to some people earlier. I don't know how many of you read about the Burmese python, in the Everglades, taking all the mammals basically, including deer, raccoons, possums. I'm concerned that this could be a problem for Florida panthers too, because if it doesn't have any prey, it's going to be a problem. And actually, Burmese panthers take leopards in Burma, so I suppose they could take a Florida panther. So this is an invasive species. So here's an invasive species that potentially could have a big impact on endangered species in the Everglades and South Florida. So here's just a summary. What I wanted to point out, a couple things here. In the Mexican wolf, these are the different guidelines that I talked about. And so we don't really know some of these things down here. This is kind of the future, but in the Florida panther, is there going to be a small effective size as a result of this introduction of Texas cougars? Are they going to dominate the ancestry? We think that is happening in the Mexican wolf, and we don't know exactly what the future is going to be. People are talking about maybe crossing with northern gray wolves. Well, this becomes a big kind of problem, and that's something I think you want to be careful about, because that's a different subspecies, and the Mexican wolf is a protected subspecies. Whether there would be something in Mexican wolves that you want to keep, they're smaller and they look like they're somewhat different in their habitats and so forth than northern gray wolves, but Mexican wolves are eating elk, so no one would have predicted that. So we have to think about the success of these. So did you give me anything yet?
Yeah.
Oh, you did? Okay. I'm being flagged here. Okay, so this is the Isle Royale, and let's go quickly through this. So this is a population that's been followed for many years. Dave Meach was the first person that started working on this in the 1950s. Small numbers of individuals. And here's Isle Royale in Lake Superior. And in the late 1990s, a male came from Canada onto Isle Royale across an ice bridge. And so these ice bridges may not occur anymore because of global warming. That's a big concern. Originally the animals came there at some point, started this population. And this is the animal, number 93, this big white Canadian male, and he really changed things on the Isle Royale population. This is actually his daughter, and she's the alpha female of this pack. And so here's the kind of thing that happens. She was pretty successful in mating with her father and producing lots of offspring. So here's in 1998 that 93 came on, and the packs on the island, and at this point virtually all the packs were dominated by his ancestry in 2007, 2009. And here's a pedigree. Here's number 93. He mated with a female, resident female, and then they had offspring. Here's 18 offspring from that mating. But then, I'm sorry. Here's their mating, and then their offspring are here. Then 93 mated with his daughter, 58. So here's the daughter. This double line means it's an inbred mating. Had 18 offspring from 93 and his daughter. And then actually, here's two offspring that mated, brother and sister, they had offspring. So we have lots of inbreeding in this population, partly because there aren't any other potential mates. And for example, the ancestry from 93 is almost 60% in 2009, and this is his mate. So we have this huge turnover, and we call it a genomic sweep. In other words, the whole genome, it changed over and now is descended from this one animal. I just wanted to bring up what's going on in Isle Royale now. In the last 3 years, the number of animals has declined, and the number of females has greatly declined. And so in 2011, they're out there now checking to see what's going on. The proportion of females is only 18%, and there's only one pack, only 11 animals. So what do you do? I mean, one thing is, do you have some artificial immigration from Canada? Because it's unlikely there's going to be ice bridges. So you actually start doing management, which the National Park Service in the past has not wanted to do. So some general conclusions about genetic rescue. I think it's an important new management option. I think we need to carefully evaluate and follow through. And I think we have to think about it as a short-term fix. It's not going to, in most cases, be a long-term solution. We have to think about other reasons for endangerment and make sure that those are still not problems in the populations of species we're looking at. Thanks very much.
I think we have time for one quick question.
how close are we to the feasibility of using genes from museum specimens to inject into populations for diversity?
I can't see you, so, oh, there we go, okay. Well, I think that would be fairly unlikely at this point. We certainly could compare populations. I mean, that's one thing. And for example, I've worked on some fishes, and we were trying to look at the ancestral constitution of fish populations, how different they are today than they were ancestrally. And we could certainly see how things have changed. But that kind of management, introducing genes through genetic engineering, well, I don't know that that's something in the near future. Suppose if there's a detrimental variant, and you could identify that variant, you might want to think about how can you get rid of that. And that would be the first case. If you're going to do it, that would be the kind of the object, I would think. Jansky and Stebbins and some of the greats of evolutionary biology were here at that point. But I was going to give you one little story from that time. This is when I met Michael Soule, and he had come up here and was talking about heterozygosity in endangered species, and people were kind of looking at him like, what are you talking about? You know, there was not really any awareness of conservation at that point, but he was trying to bring genetics
Kansas and Penn State University. He is an expert in conservation genetics and has been involved with research on several endangered species, including Mexican wolves, desert bighorn sheep, and Florida panthers. Today he's going to talk about genetic rescue in small populations.
It's my pleasure to be here. I actually came to Davis for a year in 1975, probably before many of you were born. And it was a great time for genetics at that point. I was in the Department of Genetics and into thinking about endangered species. And so he was really pushed genetics into the forefront for conservation biology. Maybe some people would say it was overemphasized, but I think at this point now we've got the tools with genomic data to really use genetics in a lot of ways to help endangered species. So I'm going to give a fairly specific example of that, and this is talking about something calling genetic rescue, and I'll give you some examples of it to show you how it may be helpful. I don't want to say that it's the end-all, because sometimes if it's not applied properly, it can not work out, and I'll give you some examples of that. So just as background, we can talk about different kinds of genetic variation. I'm going to talk primarily about detrimental variation, variants